Hello guys, welcome to Ramta Solutions and welcome to your lesson on momentum. So at the end of this video, you will know how to use this formula, and also we will help you in deriving this formula. So without any waste of time, let's get into it. So we are talking momentum. And we are talking momentum. So when we talk momentum, I'm going first to give you a simple scenario. So in our scenario, I want you to think of these two things. So let's think of one. Let's think of one. We're going to think of a mosquito. Let's say a mosquito lands on your skin. That's number one. Number two, raindrop. I'm going to say splashes. I'm still going to say your skin. And then number three, an eagle lands. So eagle lands on your hand or on your arm. Okay, hand is fine. So I want you to consider these three cases. So now in these three cases, let's think about it. Normally, you don't even feel it when a mosquito lands on your skin. The only time you realize that a mosquito has passed is after it has bitten you, right? So you only realize that the mosquito has passed after you feel your skin itching, all right? Now, again, with raindrops, I do understand that it's slightly different because they are not really the same, but you feel it when rain has dropped, when rain has dropped on your skin, right? You feel those rain droplets on, right? But these are different to mosquito landing on the skin. Now imagine an eagle, a large bird, landing on your hand. This one you will feel it because it's an eagle. It's heavier than all these three. So when you think about it, a mosquito is smaller than the other two. A raindrop is smaller than an eagle, but greater than a mosquito. I'm talking of mass. So these are not the only thing that we think are affecting this. So maybe the question I should ask is, why is this happening? Right? Why is this happening? Why is this happening? Right? Why do we feel these things like this? So one could possibly be the mass. One is heavier than the other, or others are heavy. For example, an eagle is heavier than a raindrop and a mosquito. Hence, we feel it when it lands on our hand. Right? You know, there are people who like keeping eagles as pets. Right? Or even if they don't keep it as pets, but whatever. Right? So an eagle is heavier than a raindrop and a mosquito. Again, another thing that could cause this thing to happen is also the velocity. Right? It's also the velocity. I want you to think of it in this way. When a mosquito lands on your skin, it's like it lands at a very slow velocity, right? It lands at a very slow velocity. A raindrop, the velocity at which the raindrop splashes you, or the rain drops on you, is simply because its velocity is different to that of the mosquito. The same applies to that of the eagle, right? The same applies to that of the eagle. But sometimes it happens that these two objects are landing at the same velocity or are arriving to their destination at the same velocity, but their momentum will still be different. So this then leads us to define momentum. So we define momentum as, let's define it. So we define momentum, remember, momentum of an object, right? So momentum of an object is basically the product of the mass of the object and its velocity. The product of the mass of the object and its velocity. Right, and its velocity. And its velocity. Okay, so that is momentum. Okay, that is momentum. So this, therefore, when we go back to the scenario that we gave you, the three objects, a mosquito has a smaller mass, a raindrop has a mass greater than that of the mosquito but less than that of the eagle. So we can therefore say, oh, now it makes sense why we feel these three differently. We feel the eagles landing on our hand greater than raindrops splashing our skin. Why? Because we will say an eagle has a greater momentum as compared to the raindrop and the mosquito. The reason we do not feel a mosquito landing on our skin is because it has a very low momentum. Right? So the definition says that momentum is the product of the mass of the object and its velocity. Okay? So we call momentum, rather we symbolize it with letter P, that means a bigger font, with letter P. Okay, with letter P. Now we said it's the product of the mass of the object and its velocity. By saying product, you multiply. So in short, we can say momentum is mv. Okay, you can say momentum is mv. Now what do these things mean? This guy here is a mass. We measure mass in kilograms. And this guy here is velocity. We measure velocity in meters per second. Now this P represents momentum. Okay, so momentum does not have a special unit. It does, its unit is kilogram meter per second. So it's simply that, kilogram meter per second. Okay, the product of a mass and its velocity. Okay, so it doesn't have a special name, it's like this. So you have seen now that momentum is m, or P is equal to mv. Now, this therefore says to you, momentum is a vector quantity. Okay, momentum is a vector quantity. Okay, it's a vector quantity. So remember, when we say it's a vector quantity, we mean when you do momentum calculations, it will have magnitude and direction, right? It will have magnitude and direction. Okay, so another thing you should always remember is that momentum is always in the direction of the velocity, right? It is always in the direction of the velocity. Okay, it is always in the direction of the velocity. Okay, it is always in the direction of the velocity. All right, perfect. So now we're going to try examples. Let's try example number 1. You will say a 401 gram soccer ball is kicked forward at 70 meters per second. What is, or calculate the momentum. Let's just say calculate the momentum. Calculate the momentum. So, to get our answer, we will say, from our data, the mass of the soccer ball is 401 grams. We said mass is in kilograms, so we need to divide this by 1,000. Okay? We need to divide this by 1,000. So this will be 0.401 kilograms. Now, the velocity of the object is 70 meters per second when forward. All right, 70 meters per second forward. Now we are calculating momentum. Momentum is m. That is p cross m v. What is m? M is 0,401. What is v? V is 70 meters per second forward. So let's get our answer. 70 times 0,401. This is 28.07 kilogram meters per second way forward. Remember, momentum is always in the direction of the velocity. Okay, momentum is always in the direction of the velocity. Okay, so it also happens, guys, that two objects can have the same momentum. Okay, so let's do example number 2. Example number 3, I will say a 750 kilogram vehicle or board. What happened? Okay, example 2, a 750 kilogram vehicle travels east at 110 meters per second. What is the velocity of the truck, okay, of the 2,530 kilogram truck if it will have the same momentum as the car, if it will have the same momentum as that vehicle, okay, as the vehicle. Now, to answer this question, there are two methods of doing it. You can say, I like doing this, honestly. I like doing this. I prefer to say momentum of the truck is equal to momentum of the vehicle, but I'm not going to do that. Let me just begin with, say, for the vehicle. Let's begin with the vehicle. I'm going to calculate momentum of the vehicle. It'll be P equals mv. So what is momentum of the vehicle? We do not know. What is its mass? It's 750. What is its velocity? It's 110 east. All right, so let's see. 750 times 110. So momentum of the vehicle is 82,500 kilogram meters per second way east. All right. Now, we will now find for the truck, right? For the truck, we said momentum of the truck is equal to momentum of the vehicle. So momentum of the truck would be 82,500 kilogram meters per second east. All right? Kilogram meters per second east. We are saying this because the information given is that they will have the same momentum. Right? Perfect. So we say P equals mv. Already we are given P, 82,500 equals. What is the mass? The mass was 2,530 kilograms. The velocity is unknown. So to find velocity, we divide by 2,530. All right, 2,530. So our answer is 32,61. 32,61. This is our speed. Therefore, the speed is 32,61 meters per second where? East. All right? Meters per second east. So this is the calculations you need for your momentum. Okay? These are the calculations you need for your momentum. Now, let me conclude this topic. So in conclusion, I want to remind you, we said P equals mv. What does this say? This means P is directly proportional to mass. What does this mean for us? If you increase your momentum, the mass must also increase, provided velocity is constant. Again, if you decrease momentum, the mass must also decrease, provided velocity is constant. Again, momentum is also directly proportional to v, meaning the same thing. If you increase momentum, velocity has to increase. That is if mass is constant. Okay, if you decrease momentum, velocity must also decrease. That's if mass is constant. Okay, that's if mass is constant. Okay, that's if mass is constant. So these are the things that you need to know pertaining momentum. Okay, so I have shown you that it can happen that two objects can have the same momentum. All right, I have shown you two objects can have the same momentum. So with that being said, it's a wrap, and this concludes our lesson on momentum. So see you next time when we look at changing momentum. Okay, all right, so bye-bye.